So question 103, if you're impartial to fractions, then this might be the question for you. So the starting point for expressing any partial fractions is to factorize the denominator. So when we do that, this is what we get. Now the shape of this partial fraction, when we split it out, is going to be determined by the highest power of x on the numerator and the denominator. So what we see here is this is an improper fraction. When we divide x squared by 2x squared, we're going to get a number. In fact, the number is going to be a half. But this means that the shape of the partial fractions, when we split this into partial fractions, we're going to get three parts. We're going to get a whole number part, and then we're going to get a coefficient of 1 over 2x minus 3, and then one with a coefficient of 1 over x plus 1. So we've got these three parts to deal with. Now, the way that we move now is we multiply this whole expression by the denominator here. When we do that, the left-hand side is left with just the numerator. This a gets multiplied by this whole denominator, which I've kept factorized for convenience. This term, when multiplied by the denominator, becomes b times x plus 1 because the 2x minus 3 factors cancel. And this term, when we multiply that by 2x minus 3 times x minus x plus 1, the x plus 1's cancel, leaving c times 2x minus 3. And this is still an identity. So with it being an identity, we can substitute any value of x into this identity that we like. And I've chosen x equals minus 1, which is a common choice probably, because when we put x equals minus 1 into here and here, these terms become 0. So I'm left with, when I put minus 1 into here and into here, I'm left with minus 1 equals minus 5c, and in other words, c equals 1 over 5. I substitute another value of x in now. X equals 3 over 2 seems like a sensible choice because that means that these two brackets become 0. And when I put 3 over 2 into this and this, I'm left with 11 over 4 equals 5 over 2b, from which b equals 11 over 10. So all I need to do now is to find out a. And now what I could do is I could put another value of x into the expression. Let's say x equals 0, for example. But instead I'm going to look at the alternative approach of looking at the coefficients of x squared. So I can compare coefficients of x squared on both sides of the identity. Here on the left-hand side I've just got one lot of x squared, and on the right-hand side I've got 2x times x times a, so I've got 2a x squared. So when I look at the x squared terms, I see that 1 equals 2a, and so a equals a half. Notice that when I'm comparing coefficients or looking at specific values of x, the identity is no longer an identity. These values, when I substitute particular values of x in, these are all equals now, because we're looking at specific values or coefficients. And there we have the final answer with all the correct values for a, b and c entered in. Now, with a question like this, I would always, before moving on, substitute a particular value of x into both left-hand side and the right-hand side to make sure that the two sides match up. If I put 17 into the left-hand side and then put 17, for example, into the right-hand side, a nice prime number, then I've got a feeling that, a good, nice warm feeling that I've got the right answer.